Okay, in the next step of this particular lesson on data flow diagrams, we left off with the idea of a basic system that has some input and a process. So we have a input system, or inputs to the system, and we have outputs from the system. Notice that I use particular shapes for this for each of these, and I'll get into that next, what these particular shapes mean. But the important thing at this level here is that we're dealing with what's called the context of the system. See if I can get that spelled out here properly. We have it puts the system, the P, in context with the rest of the application, or rest of the outside systems. And we're going to look at an example here of a zoo management system, an application that would be responsible for, a software application that would be responsible for running the operations of a zoo. In this case, we can see here the center section here. This is the actual process called the zoo, and we have members over here that are providing money and requests and so forth as input to the zoo. We have suppliers on this side that provide animal feed, invoices, etc. as input to the zoo. And then the zoo may produce some baby animals or registration papers, whatever else that might get generated from the zoo. Will also generate educational materials and so on. These would be considered output types of reports. This is the zoo again in the center. That's the P part over here. Go back to this slide over here, and that's the context that we're dealing with. And actually, let me see if I can go back here and review on this one. And I just want to erase this part here. Okay. Now, if we look at the zoo, the goal is to be able to divide or to break the main system down into different subsystems. So we're going to have individual components: animal care, produce reports, human resources, take care of payroll, scheduling, things like that, and which we've talked about in the past. So these are all going to be subsystems, and then we put the subsystems in context with the rest of the application. Now, a quick note about the different diagram or objects that we have here. So the rectangles that you see in these data flow diagrams, these things represent what are called external, that I'll put in there properly, external entities. And then the rounded shape rectangles, rounded edge, or I'll draw them over as circles here again, kind of highlight that. The circles will be considered the actual process. This is the piece of the software application that actually does something. Then we have the kind of open-ended rectangle here, or what I like to do is draw the database symbol, and this is a data store or a database. And again, this is where we would store information. Then we have lines that go between the different objects, and those are the actual data flows. And that's the important piece of information that you as an analyst would have to be able to track. So given those basic shapes, we can now look at what's called the zoo level 0. Now the level 0, go back over here, the level 0, oops, looks like I lost my inking. Go back over there. The level 0, what that does is it takes the basic high-level processes and starts to map out what they do and how they communicate with each other. And again, I have my standard input and an output process or output entity. Again, these are not processes, those are entities that I'm flowing information into and out of. And in this case, if we go back over to the zoo example, we have donors that are sending in the money and request here. And we have a process called donor and public relations that accepts that particular set of money and then does something with that. We also have animal care, and this would be the main zookeepers, of course, and they're going to be responsible for keeping track of how the animals have been fed, shot records, cages cleaned, and so forth. So for example, if we need to have a request to maintain the lion cages to be able to provide or to clean up the lion cages, we're going to send that over to managed facilities. Managed facilities would then generate a maintenance schedule here, maybe on a weekly basis. And so we have a request to clean the lion cages for next Tuesday. The facilities say, okay, we're going to go ahead and schedule that, so you better make sure that you have the lions out of the lion cage when we go over here to that area and clean them out. Now, what would happen if we didn't get that schedule published in time? Well, then the cleaners would, maintenance people would show up to clean out the animal care, and they might become lunch, and then we don't necessarily need to have suppliers providing food for us. Of course, that would be a bad thing. So the idea here is that these data flows going back and forth are very important pieces of information which keeps all the subsystems, 1, 2, 3, 4, etc., all communicating with each other. So again, notice that I have specific shapes. I am numbering each one of my processes appropriately. And then what I can do from there is I can break this down and go even a step further. And so if I look at the level, what's called a level 1, go back over here, and I go down to oops, get my ink going again here, to level 1, is I would take one of these steps here, one of these processes, and expand it out. And if I had 3 dimensions, this would be like a higher, or actually a lower level dimension with multiple steps within it. And I would have data flows moving between the different steps. And maybe instead of going to an output, I'm going to save the information to a database. I still might have my input here, providing input into step 1.1. And so the idea that now I can start to describe what this high level 1.0 is all about. If I go back to the zoo, this would be the donor level, which is combined of creating public relations documents, handling donor requests, etc. So let's say if I have a program to adopt baby animals, and let's see here, go back to here. If I have baby animals, say maybe a database of baby animals that need to have adopting, I might to put together a set of web pages to track the needs for those particular baby animals and also handle the requests that come in. So then I can match up the request to the needs, and again maybe produce a web page where somebody could put in a credit card number and then save that information. So now we have a way to be able to identify which animals are available and the donors that are supporting them. And once I have a data store that looks like this down here, I can start to identify and determine, okay, for baby animals, I'm going to need certain types of information. Maybe things like the age, weight, sex, and a variety of other things, special needs, whatever it might be, and I can have that listed in into the database. And this then kind of goes back to our discussion about databases. How do we design this particular data store or table? And this would give, at this level here, again, would give the MIS person enough information to be able to describe or create a database table. And so then we can arbitrarily, we can keep on going even further. So I'm going to go back over here to my whiteboard. I could go to a level 2, and I could take, say, this process 1.4 and blow that out into more detail. And in this case, I'm going to have a 1.4.1 and a 1.4.2, etc. And the idea here is that as I go into more and more detail, level 2, level 3, etc., I end up using this extended dot notation to represent each level. This helps the MIS or computer science person understand the level of detail. So I'm having more detail as I go lower and lower into the diagramming.